Okay, so I'm making this little video in review for Chapter 8 test that's coming up. So from the very beginning, we talked about the kinetic molecular theory. So kinetic means motion of molecules, and this theory accounts for a lot of the different phase changes and different things that we see in science. Brownian motion is that erratic natural motion that all particles exhibit. The kinetic molecular theory has 5 main points here. All matter is made up of moving particles. Different substances have different particles. Particles are in constant motion. The more energy they have, the faster they move. The attraction between the particles gets weaker the farther apart they are. And this is a good explanation for, like I said, the phases of matter. Solids, they don't move very much, and they're closer together. Attractive forces are stronger in solids. Liquids, the attractive forces and the motion forces are relatively balanced, and liquids fill the shape of their containers. They're not rigid, but they do move a lot. And in gas, they're very far apart, and the interactions between them are virtually nothing. They're moving so fast. So there's a few definitions here, including condensation, evaporation, sublimation, freezing, and melting. So you need to know those. We talked about temperature. Please know the similarities and the differences between the Celsius and Kelvin temperature scales. Kelvin starts at absolute 0. That's the big thing about Kelvin. There's no negatives in Kelvin scale. And the size of each Kelvin and each Celsius degree are the exact same. So 1 degree Kelvin change, or 1 Kelvin change, is the same as 1 degree Celsius change. The Celsius scale is based on the properties of water. 0 is where water freezes and melts, the same temperature, and 100 degrees is where water boils. The Fahrenheit scale is not based on properties of water, and we don't use that one very much. Okay. Thermal expansion, so as things heat up, particles gather more energy and they spread apart from each other. And so generally things expand as they get hotter, and they contract as they get cooler. There are some formulas related to that. This is the expansion formula, so linear expansion. The change in length of an object is found by multiplying the constant of linear expansion for that particular material times the original length times the change in temperature. It's very simple. You'll be given on your quiz or test here, you'll be given constants. You don't have to write those down or remember those. And down here, the volumetric expansion formula, very similar. You have a volumetric expansion constant, and the change in volume then is that constant times the original volume times the change in temperature. Okay, so you'll either have to memorize those formulas or put them on a cue card, or they'll be given to you depending on your teacher and what they've agreed with you. But you should know how to use those. Okay, so we did some sample problems there before, calculated change of length and that sort of thing. Hopefully your homework is all done, so you've had some practice with that. We talked about thermal energy. Temperature is the measure of average motion or kinetic energy of atoms in a material. That's the temperature. The temperature and heat are very different. Heat is the transfer of energy. Okay, so heat is the transfer of energy that flows from a cold object or a warm object to a cold object, that sort of thing. So you'd be well to review these notes. The calculation of energy related to a temperature change of something would be this formula. So E equals M times C, the specific heat constant, times the change in temperature. So that one, you'll have to know how to use that formula. And the specific heat constant there is specific to each different material. E equals MC delta T. So we also talked about heat, the different types of heat transfer, conduction, convection, radiation. And what else there? Oh yeah, finally, I think this is near the end, we talked about calorimetry and how we can, when something loses energy, something else gains that same energy. So energy is neither created nor destroyed. That's a law of thermodynamics. And so if something heats up, it takes energy from something else. If something cools down, it gives off its energy to something else. And we can do some very careful calculations by if something is burning inside a calorimeter, it gives off its heat energy to the material that is surrounding it. And if we measure the temperature change in that material, we can reverse calculate the energy that this thing is giving off. So that's called calorimetry right here. All right, we did some calculations on heat exchange there. And I guess this might be the final thing that we did, change of state and latent heat, the heating-cooling curves, right? So you'll remember these. When there's a temperature change, that's E equals mc delta T. When the graph either goes up or goes down, that's including a temperature change. On the flat part of this cooling curve, that's the phase change. And so that's E equals m times L, the latent heat. So that's another constant that's just specific to every substance. And then, of course, this one is a change of temperature again, so another E equals mc delta T. This is another E equals mL. It would be a different L, and this would be E equals mc delta T, and so on. And so you could calculate all of the energies from each section in a heating, cooling situation, add them all together, and that's the total energy that's involved. So E equals mL, remember, latent heat. Latent heat of fusion is where the melting point is. Latent heat of fusion, right here, that's LF. And latent heat of vaporization, LV, corresponds to the boiling or the change of state from liquid to gas. Okay. And so, yeah, so you can check your textbook out there, but that's those ones. So I think that's probably that's a rundown of the big things that you want to pay attention to here. You'll be given some constants for latent heat and so on. So we did some example questions, and you remember doing these in class, perhaps. And so you should be able to do a question just like this and give that answer. So you can pause this and study this a little bit if you want, and you should be able to do a question like that. Good morning, students. Welcome to the Wonder of Physics. I like that little cartoon. Wish I could do that. And let's see. Yeah, the other heat exchange kind of questions are the other ones we kind of did. Was like E equals mc delta T equals E equals mc delta T. One of them was negative, if you recall that sort of thing. Seem to do that maybe up here. So yeah, there would be a question. If you have a hot, spoon, well, what's the heat relative to that? And then water that's absorbing. So this is going to be giving off energy. This is going to be taking on the energy. That's the heat exchange questions, and you want to refer to page 240 for that. Okay, so that's a little rundown of review for your Chapter 8 exam in Physical Science 20.